So here are the equations you need. This equation is going to tell you how much space a single tangent curve takes up, and this is going to give you a way to find two asymptotes. If the number in front of A is positive, then the curve goes up, and if the number in front of it is negative, then the curve goes down. Okay, so then here are the same equations for cotangent. So putting that in action, I'm going to start off by finding how much space does just one tangent curve take up. So I'm going to take pi, which is the normal amount of space that a tangent curve takes up, and divide it by the number in front of x. So I have pi over 2. I want to graph my two asymptotes. So using these formulas, my b value is 2. My c value, there's no plus or minus a number in here, so my c value is 0. And then I still have pi over 2, negative pi over 2. So I make that substitution to solve. If I want to get x by itself, I'm going to multiply both sides by 1/2, and I end up with pi over 4. And then over here, again, multiply by 1/2, and I get negative pi over 4. So let's go ahead and graph those two asymptotes. If this is at pi, that's half of pi, that's a fourth of pi. So here's at pi over 4 and negative pi over 4. Because the number in the front is positive, I know that tangents normally go uphill when it's positive, so it's going to look like this. But what else we need to figure out is the most important point, and that key point when it comes to tangents is exactly in the center of the two asymptotes. Now you can tell visually that the center of this is at 0, but let's say that the two asymptotes you found weren't as obvious as these two. So then if you want to find the middle, you would take and add these two together and divide by 2, because you're really finding the average. And if I take pi over 4 plus negative pi over 4, I get 0. 0 divided by 2 is 0. So if it wasn't obvious, add them together, divide by 2. Okay, now, when I know the x value of that really important point that's directly in the center of the asymptotes, I need to substitute it into the equation to find the y coordinate. So I found that my key point is at 0 by adding the asymptotes together and dividing by 2 to find the middle of them. And then I'm going to substitute that number, 0 in this case, into my equation. So if I substitute in 0, I end up getting 1. Now I'm not going to take the time to go through that on the unit circle, but tangent of 0, if I go to an angle of 0, the tangent is going to be 0. 3 times 0 is 0, plus 1 is 1. Okay, so then I've plotted that most important point, and frankly, at this moment, I know enough information to make a great sketch, because if this is a positive number and positive tangents go uphill, and I know that important point, I'm going to go here and here. Now, depending on the directions, you might need to find an extra point or two, but this is definitely enough for our sketch. And so I went ahead, though, just for the heck of it, and plugged in one more number just to show you could. So if I just went with pi over 8, which is between 0 and pi over 4. If I substitute that in to here, I'm going to end up with 4. So I could plot that point, use the symmetry, and go right here. This is also another way if you're like, gosh, I'm doubting myself. Does this one go this way or does it go this way? And you've forgotten, by plotting one extra point, you now are sure that it's going that direction. Okay, so there's my curve. For cotangent, you're going to use those same formulas, the ones for cotangent, but you go about it the exact same way. You'll take those equations to find the asymptotes, and then add the two asymptotes together, divide by 2 to find the center, and then substitute that number in to finish getting the key point.